Hello, Math Studies students, and welcome to your online lesson. Today we'll be talking about finding asymptotes of unknown functions, both with and without technology. First, we want to talk about what is an asymptote. An asymptote is a line that a function gets closer and closer to, but never actually reaches. So if I were to make an analogy for this, if I were to, let's say, have a piece of string, and then I cut that string in half. Obviously, we got much smaller. And then I cut that string in half again. Get smaller still. And I cut that string in half again. And I cut that in half again. And I keep cutting it in half. How long will it take until I have no string? And the answer is theoretically never. Like there'll always be a little bit left, and I can keep cutting it in half and cutting it in half over and over and over again. Or if you were to say you've got a ball and a wall, and you keep moving that ball halfway between where it was and the wall, you're going to get closer and closer, but again, you will never quite get there. You're just going to get closer and closer and always be approaching it, but never quite hit it. And that's the idea of what an asymptote is. We get close to a value. We get infinitely close, like so close that you may as well be there, but you're never actually touching it. Now, we've talked about other lines involving graphs, like when we had a parabola, we talked about something known as the axis of symmetry, and that was a line that went right through our vertex, and it was sort of like a mirror where we could reflect one side of the graph onto the other. Now, was that line actually part of our graph? No, it was just a tool that we used to help create our graph. Well, that's the same deal with an asymptote. An asymptote is not actually part of the graph, but it is a line that shows a relation that's going on in our graph, specifically a spot that we are getting very near but never actually hitting. We're going to be talking about vertical asymptotes, and vertical, again, are ones that go up and down. And we're also going to be talking about horizontal asymptotes in this lesson. And those would be ones going left and right, like the horizon. So we're going to be looking at functions that contain fractions today. And vertical asymptotes occur when the denominator, and the denominator, once again, is the bottom of our fraction, is equal to 0. Now, why does that occur? Well, you have a vertical asymptote at a spot where you cannot have an x value. And there's so many things I can do with x. I can take an x value and I can square it. So I could plug in, if I had x squared, I could do 2 squared and I'd get 4. I could do 1/2 squared and I would get 1/4. I could square large numbers like 100. I can square negative numbers like -15. There's lots of things I can do with that. The same thing if I was adding 2 to a number. I can add 2 to pretty much any number I can think of. But there's some things that I can't do, and one of those is dividing. There's some numbers I can't divide, or specifically one number I can't divide. And the number that I can't divide is 0. So actually, let's use a number like 4. So if I take 4 and I could divide it into 2 groups. If I take 4 and divide it into 2 groups, I would have 2 in each one of those groups. All right, so 4 things, and I put one group there, one group there. 2 are in each group. Or I could take 4 and divide them into one group, and I would have 4 things in that one group. Or I could take 4 things and divide them into 4 groups, and there'd be one thing in each one of those groups. But if I take 4 and divide it by 0, well, I can't divide it into 0 groups. There's 4 things. There has to at least be one group. Or if I chop it up, there'd be a whole bunch of groups. But I can't have 0 groups or 0 things in a group because I have 4 that I'm starting with. So you can't divide by 0. So when you have a function with a fraction, we can find a vertical asymptote where our denominator equals 0. And then for horizontal asymptotes, we looked at this notation in the previous video. This means approaching. So as x gets really large, as x approaches infinity, or x gets really small or really negative large, where it's approaching negative infinity, what is happening to our values? And we'll look at some specific examples of that. So horizontal asymptotes take a little bit more thinking, I guess, or rationalizing to figure out what they are. But for vertical asymptotes, those are nice and easy because all we have to do, again, is set the denominator equal to 0. So for our first example, we have a function g of x, and as you can see, there is a fraction in our function, the 2 over x minus 1, and then whatever that is, we're adding 3 to it. All right, so since we have a fraction in our function, we know that we can find a vertical asymptote by setting our denominator equal to 0. Well, again, what's the denominator? It's the bottom of our fraction. So the bottom of our fraction is x minus 1. And we're going to set that equal to 0. So I'm just going to do like regular old algebra, one step here, railroad tracks, opposite operations. And since there was 1 subtracting from our x, we add 1 to both sides, and I get x is equal to 1. Now, what does that mean, x is equal to 1? Well, that's a vertical line, and we may have remembered that from our axis of symmetry when we talked about that. That always began with x equals. And yeah, so it's a vertical line. Any vertical line always starts with x equals, and it's just going to be that x is always 1, no matter what y is, x is 1. So that'd be a vertical line, and if I were to graph that, that would happen right when x is 1. So I would have this vertical line happening right here. All right. Now, what do we do for our horizontal asymptote? A horizontal asymptote said we have to think about what happens when x gets really large. Well, in order to do that, I'm going to make this problem a little bit simpler. What if I just started with a fraction of 1 over x? It's about as simple as I can make it. And so I have 1 over x. Now, what if I put a 1 in for x? I would end up with 1 over 1, which is equal to 1. Okay, no big deal. Simple, significant. Now, if I take 1 and let's put a bigger value in, like over 10. What does that equal? Well, that equals 0.1. Well, 0.1, let's think about that like money, $0.1. That'd be like a dime. It's not a lot, but it's still something. It's not nothing. Okay, now what if I take 1 over 100? Well, that's going to be 0.01. Again, if that was money, I've turned one whole, and now I've divided it by 100. It becomes like 1 cent. Okay, much smaller, less significant. Well, 1, 10, 100, these are not actually very large numbers when we think about how big numbers can be. I can add a whole bunch of zeros, and I can take a 1 and divide it by like 1,000,000, which when it comes to money, that's a pretty large number. But in the grand scheme of math, that's still only 6 zeros. I could add 60 zeros. And so as I'm getting larger and larger, what's happening? Well, now if I take 1 and divide it by 1,000,000, I'm going to end up with 0.0000001. Okay, well, what is that? I don't know. It's not much. Now, is it something? Yeah, technically it's still something, but if that was money, that would be essentially nothing. That doesn't even count as a cent. It's not even 1/10 of a cent or 100th of a cent. It's barely anything at all. And again, 1,000,000's not that big. What if I start putting more and more and more zeros beneath this? We're just going to keep getting a smaller and smaller value. So as x is getting larger and larger and larger in this little expression here, what is happening to our value? And it's becoming insignificant. So insignificant that it's essentially approaching 0. So as x is getting very large, it's becoming nothing. Well, now how does that relate to our problem that we have here? Because we don't have 1 over x, we have 2 over x minus 1. But again, if x was really large, and I took 2 and divided it by this really large number, such as 1,000,000,000, and I'm going to have 1,000,000,000 minus 1, you know, so something like that. Billion would be 9 zeros. And then I subtract 1 from it. How much do I still have in the denominator? Okay, technically I have 999,999,999, but I still basically have about 1,000,000,000 there. And 2 divided by 1,000,000,000 is going to be equal to approximately 0.000000000. I'm not even sure I have enough here, but I think the 2 would go there. And so how much is that? Kind of nothing. It's a little bit, but in the grand scheme of things, it's nothing. And this was only plugging 1,000,000,000 in. I could plug in a much larger number. And as x gets larger and larger, this value is becoming insignificant, or it's approaching 0 is what we'd say. So when I'm looking for my horizontal asymptote, again, I want to see what happens as x becomes really large. And as x gets really large, this fraction is becoming 0. So what do we have? We still have the 3 and the plus, but this 2 over x minus 1, as x approaches infinity, it's becoming 0. And so we have y is equal to 3 plus nothing, also known as my asymptote is the equation y equals 3. All right, so let's take a look at what this graph actually looks like on the calculator for a moment. So on my calculator, I'm going to go to y equals And I want to type in my function right away. So I've got 3 plus 2 divided by, and since we have numerous things in our denominator, this expression x minus 1, I'm going to use parentheses. So I have x minus 1, close my parentheses, and there's my function. Now I'm going to hit the graph key, and I'm going to make sure that my window looks good. I'm going to zoom 6 it to get this standard 10 by 10 in every direction window. And so what are we seeing here? Well, right away, our two asymptotes that we had previously, we had our vertical one that was x equal to 1, and we knew that because that's where our denominator equaled 0. So if I go to, I'm just looking at the graph here, I can sort of see that there's this almost like vertical line drawn right here on the calculator. And it's not really trying to draw the asymptote. It's more just like the calculator is making an error in connecting between the two parts of the graph. But we can see right there is essentially a vertical line gap happening in our graph that goes right through x equals 1. So one of our asymptotes, again, is x equals 1. Now, I can find the other asymptote looking at this by seeing where is my graph approaching that it doesn't hit. We already know, because we knew as this graph got larger and larger, that 2 over x minus 1 was going to become essentially nothing. And so I'd have this horizontal asymptote at y equals 3. Well, if I go to trace, and for once I'm not using second trace, just regular old trace, I'm going to start moving to the right. And so you can see my cursor flashing now. And I'm at an x value of about 2, and my y is about 4, but it's going down. And as I continue to the right, I'm at 3.3 now, and as I go further to the right, 3.2, and continue on, shifting my screen over, 3.1. It's like, okay, this is getting lower and lower. And in fact, if you look at what's on my screen now, it almost looks like my graph has turned from a curve into a straight horizontal line. Now, is it? Well, as I arrow to the right, you can see that my y values are still changing. So they're not exactly the same. I have 3.10, now 3.09, so on and so forth. And in fact, I can go to my window and make my x max be something really big, like 1,000, let's say. And now I go back to my graph, and if I trace now I have an x value of over 500, and you can see that my y value, next to the blue arrow, is really small as far as getting close to 3. It's 3.003. If I were to round this to 3 significant figures, it'd just be 3.00. And as I continue on, it's still going down, but it's never crossing 3. It's just getting closer and closer to 3. And so we definitely do have an asymptote at y equals 3. So x equals 1 was our vertical asymptote, and y equals 3. We see that on the calculator, and also by thinking about what happens when our function or our values of x get really large. We're going to look at one more example. So for this example, I'll try to focus a little bit less on the y and more just on the doing. So once again, for our vertical asymptote, we have a fraction here, so we can set the denominator, or the bottom of that fraction, equal to 0. I've got x plus 2. I'm going to set it equal to 0 because I don't want it to be 0. I want to know what value would keep me, or would make it 0, and I want to keep it from being that with my asymptote. So I'm subtracting 2 from both sides to get x alone, and I get x is equal to -2. So there's my vertical asymptote, a vertical line with an x-intercept of -2. Now for my other one, I want to think about what happens as x gets really large. Well, we have this number 1 that's being divided by some value of x plus 2. And if I put in a value like 1 or 2, it's going to be, 1 would be 1 plus 2 here, so I'd have 1/3. If I put in a value of 10, I'd have 1/12. What if I put in a billion or a trillion? I'd have 1 over 1,000,000,002, which is like hardly anything. It's a super tiny little fraction. And as x gets larger and larger, the value of this fraction is going to get smaller and smaller. What value will it approach? 0. So we essentially have all this stuff up here that I've circled becoming 0 as x gets really, really big. And that's how we find our horizontal asymptote. So we end up with y is equal to a value that's approaching 0 plus 4. And what is nothing plus 4? That just means that our horizontal asymptote is at y equals 4. A real quick look at the graph. All right, so I've already put the values of my function into my calculator, 1 over the quantity x plus 2 plus 4. I'm going to hit graph. Again, you can see that weird sort of almost noise that's happening right here. And where is that? Well, that's a horizontal line happening right when I'm crossing the x value of -2, and that was our vertical asymptote, x equals -2. Now, as far as the horizontal, we can see that my graph is sort of becoming a line around that value. And what y value is that? Well, I can just go to the regular trace button and just follow this to the right. And you can see now my y value is around 4.17. And again, I'm expecting it to be approaching y equals 4. So we're pretty close. And as I continue on, it's getting smaller and smaller, 4.1. And again, if I change my window and make my x really big, like 1,000, and that's really even not that big in the grand scheme of things. But now if I go to trace and I have an x value right now of 495, my y, as we can see, is 4.002, really close to 4. And as I continue to the right, it's getting even closer, but never crossing that value. So those are our two asymptotes, x equals -2 for our vertical and y equals 4. Till next time.